Welcome to this video about solving simple exponential equations. To begin, we need to understand something called the one-to-one property of exponential functions, which says that if a to the x is equal to a to the y, then x equals y. A to the x equals a to the y implies that x is equal to y. Basically what this is saying is that if you have two powers that are equal, two exponential expressions that have the same base, then the exponents are also equal, which is an assumption that most people would make and really comes from something called the one-to-one property. We use this to solve basic exponential equations by making both sides of the equation have the same base and then equating their exponents. Let's look at an example. So if we are asked to solve 2 to the x is equal to 32, what we notice there is that 32 can be written as a power of 2. And so the process here is to take our equation and write both sides as a power with the same base. 2 to the x can't really be changed, but the 32 can be written as 2 to the 5th. Now we have this one-to-one property. We have two exponential expressions that are equal. They both have the same base, and so we can simply equate the exponents. I can equate the exponents here and realize that x is equal to 5. Now, you of course probably could have just guessed the answer to this by looking and saying, hey, 2 to what power would equal 32? And that's sort of the idea, but this of course is the proper write-up for showing your thinking on that. It's also important then to have that thinking and that write-up when the problem becomes a little more complicated. So for example, if we're asked to solve 4 times 3 to the 6x minus 1 is equal to 4 divided by 243, initially we may not know quite where to go with that. The first thing though is to try to get both sides to look like a power, and the way I'm going to have to do that is to first get rid of the 4. I need to divide out the 4, and I can very simply divide both sides by 4 and get 3 to the 6x minus 1 is equal to 1 divided by 243. The next step of this is going to be very dependent upon you understanding that 243 is equal to 3 to the 5th power, that is the 5th power of 3. And so now with properties of exponents, which this is also very dependent upon, you realize that 1 divided by 3 to the 5th could also be written as 3 to the negative 5. And now I have accomplished that piece of getting two equal exponential expressions with the same base, and therefore I can simply equate the exponents with the one-to-one property. And then I get an equation that's very simple to finish solving. 6x is equal to negative 4, x is equal to negative 2/3. Now in this, there are some steps, of course, that you could skip. I definitely think you should show the step about dividing out the 4, but if you're clever enough to look at that 1 divided by 243 and realize that that's just 3 to the negative 5th power, that's great. But do make absolutely certain that you show this step. Very important that you show this step of two equal powers with the same base before you jump to the next step. Make sure you also show the step then where you have equated the exponents. These are both concept steps, so they're very important that they're shown. Of course, once you have that simple linear equation written, if you can jump to the answer down there, that's great as well. So the basic overall idea here, divide out any common factors on both sides of the equation, somehow get both equations to have the same base. Both sides of the equation need to be a power with the same base so that you can then equate the exponents using the one-to-one property. Let's look at one more example. For some students it gets a little tricky when you have fractions in there, so we'll look at another example with fractions. On this one, I see 4/5 to the x plus 1, and I see 125 divided by 64 to the x. And initially, you may not be quite sure where to go with this. The trick is that you definitely have to understand that 5 cubed is equal to 125, and 4 cubed is equal to 64. That's something you have to recognize. And so 125/64 is just 5/4 cubed. So that is a piece that you simply are going to have to recognize in order to move forward with this problem. So now, knowing that, I can begin by trying to get the same base on both sides. First, I will rewrite the 125/64 as 5/4 cubed. All of that, of course, is then raised to the x power. Knowing my properties of exponents will take me 2 more steps with this. First of all, to get the same base, I clearly have to flip over the 5/4 and get it to be a 4/5. I accomplish that by using a negative exponent. So that becomes 4/5 to the -3. All of that is still raised to the x power. And we also know the property of exponents, which says that if you have a power raised to a power, you simply multiply the exponents. So I have eventually accomplished the feat of getting 2 powers equal to each other with the same base, and then I can use my one-to-one property to equate those exponents and finish solving the equation. Again, the piece here is that if you can go from this step to this step right here because you actually understand powers and properties of exponents and reciprocals and all of that good stuff, that is great. That's actually really where you should be with exponents. But do show this step about equating the powers with the same base, and show this step about equating the exponents because of the one-to-one property. So that brings us to one final example that may be important here, and that is to look at something like 7 to the x is equal to 25. So when I look at this, I'm trying to get the same base. I know that 25 is equal to 5 squared, but I need to get the same base. So does 25 equal 7 to the something's power? Well, not anything that seems to make any sense, not anything that is very straightforward. And this is the big question then. How do we solve an exponential equation if we can't get the same base on both sides? And that is something that we will be looking forward to as we continue our work with the various operations on functions.